Okay, so now we have there's a bunch of words right here. Let's go ahead and take a look here. So it says application of long division and synthetic division. Well, they are good because, well, we can divide them, right? And if it happens to be a factor, it allows us to factor completely. As I said before, we're in Algebra 2 right now. In pre-calc, you are going to need to factor completely so that we can see how the polynomial graphs are being drawn. We also want to see if the number it's a root. Okay, now, so this is where things are going to be just a tad more complicated, but we'll not go too deep. Now, let me make sure that you know what a root is based on what we learned before. Now, what we learned before was this. Do you still remember quadratic equations? Okay. So let me go ahead and draw you a sample graph right here. Let's just say the x-intercept here is -3, and this is 1. So in this case, well, we would say, oh, what are the x-intercepts? We'll say the x-intercepts are -3, 0, and 1, 0, right? Now, there are a few other terms that are actually relevant. They're not exactly equal to each other, but they are closely related to each other. And you will see this on the SAT. The other word that is closely related to x-intercept is called root. Root, it's when we say, oh, yeah, what are the roots? X equals to 1, x equals to -3. So we have two roots here. If you have a quadratic equation, which is some sort of x squared function, you should expect two roots. If you have a cubic function, like x to the third power, you should expect 3 roots. If you have x to the fourth power, what's the maximum number of roots? There'll be 4 roots. Okay, so the power actually indicates how many roots, how many x-intercepts it's supposed to make. Now, there is actually another word, okay? There's another word, that it's saying the same thing. So we would say, how many zeros are there? And we say, oh, there are 2 zeros. The zeros are 1 and -3. And I think this is also the terminology that we see on a graphing calculator. Can you find the zeros? So the other name for roots, it's called the zeros, okay? So you will see these terms every now and then. And now there's something called remainder theorem. It looks complicated, but we'll see it in a moment, okay? Now let's not worry about this for now. Let's not worry about this for now. Let's go ahead and take a look at this, number 4. Now you've got this f of x, right? It says 2x cubed minus 3x squared minus 7. How would you do this? If I say, can you find out f of 3? What would you do? Or actually, what does it mean when we say f of 3? X is 3, right? So we will simply we say f of 3. We'll say, all right, let's go ahead, substitute. And I'm going to show you the substitution. So you have 2 times 3 cubed is what? 3 cubed is 27. And then minus 3 times 9 is 27. And then minus 7. Ooh, okay. So we have 54 minus 27 minus 7. So that should give you 27 minus 7, positive 20. Okay. So now, so we know the answer. It's 20. Now, this is the thing that you learned back in Algebra 1, the normal way, right? We say f of 3, you know the meaning, x is equal to 3. Cool. Now, what I'm about to show you is this. You can actually do this. And this is what blown me away. Now, there's a missing term right here. I hope you recognize that. So what you can do, and this is how I would set up my little synthetic division. You may do this, whichever way you prefer. I don't mind. So you put the 3 right here, okay? If it says f of 3, you put a 3 right here. So we do the synthetic division, just like before, going down to 2, and then we start multiplying and adding. And the remainder is 20. Did we see 20 somewhere?
Yeah. Your answer is the remainder.
That's the whole point of remainder theorem. Okay, that's the whole point of remainder theorem. So now ask yourself, would you like to work with some big numbers like this? Or would you like to do the division to get the same number? Synthetic, right? This is what blew me away, because back in the days, if I have to do this kind of find the value of f of something, I would just substitute. And I would be like, that's easy, that's common, right? But then you might end up working with some gigantic big numbers in the hundreds. And I'm like, I'm afraid that I actually would make a mistake. So the appearance of this synthetic division really helps us out. And because it is not just synthetic division, it helps us to substitute and find the values. So we give them a very special name. This process is known as synthetic substitution. Okay, this process is known as synthetic substitution. Okay, so we get 20 either way. Okay, with the substitution or with synthetic substitution. So now let's go ahead and try number 5. Okay, let's go ahead and try number 5 and see if you can find out what f of -2 is.